In this part, we are going to start handling the topic of object-oriented programming in Python. So the first question that we need to answer is obviously what is object-oriented programming? If you have not had any experience with object-oriented programming in other programming languages or in Python before, then the simplest explanation of this paradigm can be summarized as object-oriented programming is such a paradigm that focuses on structuring your program in the form of objects. Each of those objects represents a logical concept, the part of your program, and encapsulates the data and the code related to that concept. For example, when you are writing a program that represents some real-world system, for example, you are writing a diagnostic system for a car, it is then logical to split your program in separate submodules that would represent diagnostics for individual components of your car. For example, you can have a separate submodule for diagnostics of your engine, and then another module for diagnostics of your generator, and then another module for the diagnostics of your wheels, and so on. And each of those modules will contain both the necessary data to handle this part of the problem and necessary functions and code. And to make the thing even more complicated, your objects will basically contain each other. For example, you will have a main object that represents the car as a whole, and then individual components will go inside that car object as properties and attributes of that object. On the other hand, object-oriented programming is not limited to only physical world objects to be represented in such a way. One will start thinking about more abstract concepts. For example, a file on a disk can be considered an object of a physical world as well, and you can have a handler object that will wrap around the information about the location of that file and the ways to access it, and at the same time it will also contain helper functions that will allow you to read and write from that file. And we have already seen that in Python when we were accessing individual files using the open. We were creating a file handler object which had all the necessary components to access the file for both reading and writing. In a similar way, in programming, it is typical to create objects that handle database connections or pretty much connection to any external service. Or as you have seen already, a CSV format reader object that converts a CSV file into individual values of individual columns. And finally, even the application itself can be considered an object. And while in Python this is not so common, this approach is widely used, for example, in Java, where basically everything is an object of some class, and if you want to start a project, you basically create an instance of that class, and there is no other way. Let's have a look at a simple class that represents data stored in the database. We will use the same table that we used in our CSV reading example, but in this case we're going to use not dictionaries to store the final result, but a class. And the main advantage of using a class over dictionary is that class actually guarantees at least some level of structure for that object. In the case of Python, it is of course still your responsibility to provide code that will be necessary to handle those structures, because classes in Python are still extremely flexible compared to other programming languages. But nevertheless, the tools are there for you to use. In this slide you can see we have a class person, and as you can see the classes in Python are defined using the keyword class in front of the class name. And it is conventional in Python to name classes using so-called camel case, or by capitalizing each word and without using any underscore symbols in the class name. And this class contains two methods. One is def __init __. This is a special method that is called constructor. And the second one is _wrapper . This is a special method that allows class to represent itself for debugging purposes. The constructor method is a special method that is called every time the object is created, and you will have the constructor doing some initialization of the object after it has been allocated, but before it can be used by any other object or part of your program. Constructors typically include setting default values for a variable, accessing the arguments that have been passed to your class object during its instantiation. For example, in this case, we have name, surname, and age passed as arguments. and creating necessary objects inside the class. For example, if your class is representing or using a database connection, then constructor would be a perfect place to create a new instance of such database connection. Other than that, this class is a very minimalistic one. It only takes 3 properties, which are stored in its object. And you can see the special object that is named self. This is the first argument that is passed to every function. It is passed implicitly, and it represents the object itself, so that the object can reference its own properties and its own member functions. In terms of Python terminology, everything that is inside of the class is considered its attribute. It can be either a property or a function. In some programming languages, such functions will be called member functions because they are member of that class, but in case of Python they are also called methods. In this case, name, surname, and age are properties of the class, and we consider them properties because they contain just some values rather than functions. In Python, properties can be either a class member property or instance member, and the difference between them is that class member properties are effectively shared between all instances of the class and are stored in the object that is represented by the class name itself, while instance members are properties and methods that are associated directly with the instance of the class, so the objects that you have created when you have called the constructor of that class. And if you are using both, for example, you have one class member property that is named A, and it has some value, for example 5, and then in an instance you write self.a equals 10, then you effectively shadow that class member property with your instance member. But all the rules of passing by reference and by value also apply here. So for example, in this case, we are having some class attribute that is passed by value, and in the function foo of this mixed class, we assign new value to it. And as you can see, if we have 2 instances of that mixed class, MC1 and MC2, then if we called MC1.foo and passed 10 as an argument to that function, then as a result we will only see value 10 assigned to the instance MC1, and instance MC2 and the original class will still contain value 20. On the other hand, if we are going to have a list as a class attribute, then assigning new value to element 0 of that list will result in that value being changed in both instances MC1, MC2, and even the class itself. So when we are going to create a new instances of that class, they will also carry this change along. In both of the 2 previous examples, we have created instances of mixed class by simply writing the name of the class and round brackets. In this case, we have not passed any arguments to their constructors, so the brackets were empty. We will have more examples of instantiating different objects from classes in the next parts of this lecture. But for a moment, let's divert to the life cycle of the objects in Python. First of all, I should note that in Python, all objects that are created, since they are passed by reference, the reference tracking system is used to manage their end of life. For example, when we are creating an object, we first create an instance of a reference to that object, and then we can copy that reference to another variable or pass it into a function or send it to some storage, for example, into a list. And every time we create a new reference, we will increment a counter that is associated with that object by 1. On the other hand, every time a variable that falls out of scope or gets deleted, the counter will be decreased by 0. If during the lifetime of an object the counter reaches 0, that no other object references instance of that object anymore, and it is safe to call destructor of that class and then deallocate memory. On the other hand, in some cases objects will reference each other, and in such cases neither of the objects' reference will reach 0 because they will be supporting each other's existence in such way. To help with that situation, Python has garbage collector. Garbage collector is a special algorithm that is used in many programming languages such as Java, for example, or C#, and the purpose of this algorithm is to detect the objects that have fallen out of the scope of the program itself. So, for example, even if you will have still those objects referencing each other, but no other object from your main block of code, for example, starting from your application as your main object, or a list of global variables will no longer be able to reach those objects by referencing, then the system will know that these objects are actually deprecated and should be removed from the memory. The algorithm is actually quite heavy and it is not run frequently, so you should not rely on that all the time, otherwise you might risk running out of memory with Python program or cause unnecessary overheads. So the advice is not to create any circular references between objects whenever possible. And by circular, I mean not just two objects referencing each other. It can be a chain of objects that references one another, and then the last object references the first one. And this will prevent objects from being deleted by a reference counting algorithm. Okay, so to summarize, whenever you are creating a new instance of the object, you are calling the class and pass arguments, and these arguments go into the special method, the init method, which is a constructor for that class. And inside that method, you initialize your class instance, you create default values, you create some objects that are necessary for your class operation, and after this method returns, you can actually start using this element in your program. Then you pass these objects around by reference, copying them or deleting them, and during that you increment or decrement the counter, and once that counter reaches 0, the object is no longer in use by anything, so the system triggers the destructor method, __del, __, and that method is used not so frequently, but sometimes it is necessary to do some cleanup. For example, if you have created any connections to databases or other external resources, it is a good place to destroy those connections. And finally, once that method returns, the memory is freed and is reusable by program again. And if the method is never triggered by reference counting algorithm, then eventually there is a chance that garbage collector will detect that it is deprecated and detached from the main tree of objects that reference each other, starting from the list of global variables or your application object, and delete that object in a similar way as if the reference count decreased to 0. But this might happen very late after your object have actually fallen out of the scope of your execution.